All right, welcome back. Let's get to the next part of our class. We are going to, right under evaluate, create another private void, the private method called evaluate, right under pre-evaluate. It will go directly into a loop that starts at break in. So break in initially is equal to 0. If we broke, then break in will be equal to whatever n we broke on, whatever index we broke on, plus 1. Okay. Okay, I just totally moved that up, didn't I? So our goal is unconditional programming, unconditional coding, that is. But if you've ever tried to write an application without any conditions, you know that sooner or later it becomes impossible. And if we were following this condition, we would not enter, and we would still process our base shape just like this wasn't. We wouldn't have this condition here, and since our base shape was 0, it would do nothing. But we're not quite there yet. We can get there. Unconditional programming or non-conditional programming is impossible. You should always try for non-conditional programming, because a million conditions just slows things down. Too many conditions slow things down. And although you cannot get rid of all of them, you can get rid of a lot of them. At this point in our code, though, we cannot. Our nugget neighbors, there's more than 17 possible, but we're just going with 17. If we go over to common, actually, let's see here. We only have 13 defined with none, but I defined 17. We need to get our neighbors. This is where we decide what sides we are going to create of this nugget. We make it read none. I saw a couple people try to do voxel and hexagonal programming by creating all the sides every time and just cover them up like you would in 2D programming or 2.5D. And they don't understand why they get such horrible FPS frame rates. And that is because the shader, you're forcing, when you draw parts of the model that are going to be covered up, the shader is still having to process for that. And You're still processing for that side that you've covered up. And it's just very overwhelming on your GPU. So if a side is covered up, well, we're not going to create that side. What? Okay. So if our row of this nugget is greater than 0, when we're dealing with multiple chunks, we'll actually check for the chunks row also. But if our row is greater than 0, then we probably have something behind it. And that's what we're going to set this neighbor to. Our next one, if our column is greater than 0, hold on. If and our column is even, else if our row is greater than 0, else we'll just do that. So if our column is greater than 0, if it's not, we're not going to touch this. If it is, and we are an even column, then then neighbor 1 will be our nugget index -1. We could use get CR index for this stuff, but we're not. Right now we're not. If our row is greater than 0, because it could be behind, this will probably be behind us if we look here. If it's not 0, my wonderful drawing. So if this is an even column, 0 or 2, etc., then this item will be our nugget index -1. If it's not even, then this one is on the previous row behind us. And else, then we'll just set it to 0 for now. When we get to multiple chunks, we'll do something a little different. Alrighty. This one, comically, we're still looking at the column. I'm keeping them separate, although we could combine them together. I want this for debugging to be separate. So if we are even and our row +1 is less than our nugget count, then it is this one. Well, if it's even, then we need to go all the way to the row in front of us and then come back 1. Flip these two around. So else, if it is just C even, then we're on the edge and we don't need to set anything. And if everything else, it'll be we're on the same row as the previous column. This is really, in my opinion, the most annoying function we have to do. Because it gets worse when we get to multiple chunks. And yeah. So this is right in front of us. If our column plus 1 is less than our nugget count, is our nugget index plus our nugget count plus 1. If it is even, it will be 0 once again. Else, because this is all on that side. Alright, so if our column plus 1 once again is less than the nugget count, and this is even, then it is our nugget index plus 1. Else, if our row is greater than 0, then it is actually more like this one. Flip those two around. It is minus our nugget count plus 1. Yeah. And then else it is nothing. Now we have the top and the bottom, and these are really nice and easy. If y plus 1 is less than our map level max height, then our 6 will be our nugget index plus our level size. Else it'll be equal to 0. And for our 7, if our y is greater than 0, it'll be minus our level size. We are going to not create the bottom, the very bottom, so that one will actually be equal to 1. So there it is. Alrighty, back to the evaluate, if I can get to it. Alright, I need to also initial, but first, let's set us, but we need to go create our base shape. just go up to the top. I like to keep all these together, so I put it right there. And after we do this, let's go right down here, is equal to scriptable object dot create instance base shape, and then initialize it. What's wrong with you? Materials. Oh, okay, my bad. Material presets. Down here it's a length. Up here it's we actually pass presets through. Alrighty, we're gonna do another try catch here. So, since these cross into each other's world, we don't multiply this times 1. We have to multiply it times 0.75 to get our x of where we're, or of our left x of where we're drawing it. So we're given that same 2,400 vertices per nugget limit. That means whatever you model in Blender needs to be below 2,400 vertices. That's our mark where we break off. If you want to make that larger, go ahead, but remember there's only 60,000 vertices per mesh at maximum, or 60,000 plus. I think it's 64,000 something. 64,000 or 65,072 or 64,072 that Unity can handle. So you want to stay well beneath that. All right. So our post evaluate, we're going to set up our temporary arrays and copy everything that we put in our full arrays over to them. Now we could just resize our main arrays over and over again versus copying over and over again, but I'd like to do it this way. It ends up being about the same. So first of all, we're resizing the temporary vertices to however many vertices we have. Then we're copying that many vertices from our main vertice list to our temporary vertice list. And we're doing this for the vertices, the UVs, and the normals. And later on, we'll also be doing it for the tangents. Now we need to copy over the face indexes. Or say that we didn't use a certain one. I guess that the array work is what's really annoying to a lot of people. And why they give up. So coming from a C++ and Visual Basic 6 background, that's what I took in college. Well, actually, Visual Basic 4 is what I took in college. This is not nearly that annoying to me. It's just something that has to be done. You just gotta once you get it done, you try not to change anything so you don't have to do it again. And now I'm trying to teach a class on it on YouTube and Udemy. That's making me type it over and over again. Okay, now we need to do the create mesh. So we split our create mesh up into two parts. The second part, the create mesh 1 will become larger later on. We do this because these have to be done on the main thread, and we would like to break them apart across frames. You won't notice. You won't notice any blips or glitches or anything. And we will also like to put some coroutines in here later on. So, first thing, if we did split, or we did break on our evaluate, and this is a later pass, then we want to create a child for it if it does not exist yet. Somewhere to store our mesh, to show our mesh. Now, I prefer to work with custom shaders, so I prefer to draw the mesh myself. And that's how we'll go later on. But for this moment, we're just going to use the mesh filter. Microsoft keeps on hiding my mouse. That's annoying. Now there's almost no chance, no, there's no chance that our mesh could be null in this pass. But we're going to go ahead and do our null check. Just to get into the habit. Null checks are almost a unused idea in graphics programming, because normally if you're doing a null check, something's already broke. So why you should already have exited. So why slow everything down? But I know a lot of people have been clamoring for them. Even on some of the Unity forums, asking the Unity developers why they don't do null checks. Well, normally you don't do null checks because you've crashed or you've exited it before something could be null. So we are going to have a double indexer here. I always use M because O looks too much like 0. And I normally use I other places. So our face index groups match our materials. So we're just going to grab the material that matches the index groups in our index. But here we're not using all of our materials, and we're not creating a sub mesh for every material because not all of them have faces. So we use our second indexer there, and we have to increment it. Sure, some of this stuff is simplistic to a lot of people, but I don't know what is. All right. Microsoft, I haven't touched create yet. So why you keep on shoving it in there? IntelliSense got so good for a little while, and then just something happened to it. So even when we draw the meshes ourselves, we'll still have to have the collider. So we'll get rid of the mesh filter and the mesh renderer and use graphics draw. Because I find that easier to work with the material properties class. Then you can use the materials property class to set custom properties on your shaders. And you can do that with a mesh filter, but I find it more cumbersome. I find it much easier to do it if you have a method to draw the mesh yourself with the graphics object, graphics class. So let's see if I can't. Get all that into view. And next up, we return to Unity and set up our chunk. See you there. If you're getting something out of this, do subscribe, please. Thank you.